Hello everyone, I'm here to share with you 3D printing training for surgical planning models. I am Archie Velasco, the director of FAB LAB Mindanao, located here in the Mindanao State University Iligan Institute of Technology here in Southern Philippines. Now, MSU-IIT is currently the Network Growth Chair of the Philippine FAB Lab network called FAB Labs Philippines. We are a group of digital fabrication laboratory and open maker spaces spread across Luzon, Visayas, and Mindanao. Here is our map for you to see what FAB Lab is nearest you. Now let's start this presentation with the usual process of medical professionals, doctors, and surgeons who would want to use anatomical models. Now, usually, the doctor or the surgeon gets the DICOM file from either MRI or CT scan. Now, this doctor will send this DICOM file to a fabricator located somewhere, and this fabricator will develop the prototype, okay, manufacture it, and then physically send the developed anatomical model to the doctor. Now, this may look like a very simple process if we do not consider distance and location. But if we are to consider the distance and location, it will look something like this one. Okay. Now, I've asked some few practitioners, and usually the fabricator that fabricates their anatomical model can be found in Japan, in China, maybe in Singapore, or maybe in India. So if you're a doctor from the Philippines and you have a DICOM file from your CT scan or from your MRI, you can send that via email to the fabricator, assuming that you already have a contact with a fabricator that will develop your anatomical model, okay, either in Japan, China, or in Singapore, or maybe in India. And then the fabricator will make the anatomical model based from your DICOM file and physically send the model to the doctor. Now, considering this a logistics setup, it will really take time. Now, a good solution is to use 3D printers, which is one of the most ubiquitous technology found in FAB Lab. Almost all FAB Lab, I mean, not just almost, but all of the FAB Labs in the Philippines have a 3D printer. So it will look something like this one. If you're a doctor from Mindanao, if you're a doctor from Luzon, from Visayas, or from Luzon, you can go access or you can keep in touch with the nearest FAB Lab on where you are located. You can send them the DICOM file from your MRI or from your CT scan, and then they can give it to you physically, or if not, send it to you via courier, the anatomical model that they have developed using their 3D printers. Now this is a good solution. But what if there's an even better solution? What I am proposing is to bring the 3D printers nearest to the doctor, to his or her hospital or his or her clinic, whereby the doctor can just extract from and manipulate the DICOM file from the CT scan or from the MRI, okay? Segment this on whatever the doctor wants, bones, tissues, skin, and manipulate this, prepare this to be 3D printed so that the doctor can just use the 3D printer on its own and come up with the anatomical model that he or she can use right away as a surgical guide or as part of the surgical planning process. Now, this is a very good solution that uses technologies of the fourth industrial revolution or industry 4.0, by which we democratize access to cyber physical systems and empower and capacitate the health professional to be not just the health professional, not just a surgeon, but be the fabricator itself. Now, this is the inspiration on why we implemented FAB Health last July 17, 24, and 31, 2021 in partnership with institutional partners, hospitals, FAB labs, and industry partners for us to develop a project that will collaborate those in the medical field and those in the digital fabrication field, as well as capacitate these doctors in 3D printing for surgical guides. Now, the way we implemented this is that we partnered with the northern and southern chapters of the Philippine Society of Otorhinolaryngology-Head and Neck Surgery with the help of the professional network of Dr. Renter Cafino of the Zamboanga City Medical Center. We were able to onboard doctors and surgeons from 4 different hospitals in Mindanao. We had 1 trainee from Zamboanga City Medical Center, 1 trainee from Mercy Medical Center, 1 trainee from Northern Mindanao Medical Center, and 2 trainees from the Southern Philippines Medical Center. So that's 4 cities: Zamboanga, Iligan, Cagayan de Oro, and Davao. But it's not just enough to onboard these doctors. We also had collaboration with makerspaces and FAB labs. So we partnered with the ENT HNS MiniMakerspace, the FAB lab located inside Zamboanga City Medical Center, along with FAB Lab Mindanao in MSU IIT and DG Hub FAB Lab Davao in the University of Southeastern Philippines, USEP in Davao City. So the collaboration looks like this. Okay, the doctors and the hospitals collaborated with the nearest FAB lab within their vicinity, because the training program that we implemented is a hybrid of online as well as face-to-face hands-on activities. Now, we started to identify that the FAB labs in itself, the FAB lab personnel, needs to be trained before they can train the doctors. That is why, since ortho and ENT, according to research, are the most common users of 3D printers in developing anatomical models, we consulted with health professionals who have been using already 3D printing as surgical guides. So we have 1 from Zamboanga City Medical Center to train our FAB labs, and 2 from the Department of Orthopedics of the University of the Philippines, Philippine General Hospital. So we were so much grateful to Dr. Cafino, Dr. Grossman, and Dr. Bubundok, who were our resource speakers, along with Justin Gabitan, our industry partner from Puzzlebox 3D Solutions Philippines, and they trained our FAB lab personnel through the industry lecture on additive manufacturing in the design and fabrication of surgical planning models. So we were having we were having mentoring and training sessions with those health professionals who were already using 3D printers as part of their surgical planning. And they trained the FAB Lab facilitators who will then be training the doctors. So the first objective, actually the primary objective of the training program FAB Health is simply, this is very simple. It's simply to transform the DICOM file that is being generated by either MRI or CT scan maybe into a physical model, okay, that can be used by the doctor for surgical guides. Now, since we started with members of the Philippine Society of Otorhinolaryngology-Head and Neck Surgery, the one that we used as use case, we had a DICOM file which is a mandible, and that was the one that we used as a use case for the activities that we gave to our trainees, so that in the end they can see on how they can use the final output for models and surgical guides such as this one. Okay. Now, there were 3 sessions. For the session 1, the goal was to train and introduce the conversion of DICOM files to .stl files. Now you see, STL is the universal file for 3D modeling. So it's the JPEG of 3D, the MPEG of 3D, the MP3 of 3D. If you can convert the DICOM file generated by MRI or CT scan into an STL file, you can actually make almost anything, manipulate almost anything. So this was the DICOM file that we used for the activities with our participants. Okay. And since it was online, we were grateful for Justin of Puzzlebox 3D to be our trainer, and our participants, our doctors, were interacting. And this is just the screenshot of using 3D Slicer, the software that we used to convert the DICOM file into an STL file. Now, for session 1 also, we used Mesh Mixer for us to introduce how to manipulate the converted STL file. So this was the use case, and in this case, I think we used mirroring as one of the tools, and there are actually more depending on the case. But in this use case, we just converted the DICOM file into another STL file by manipulating. I think there are other tools, such as other tools that other than mirroring that were used, but the goal is to come up with a manipulated or modified STL file. Okay, and this was what our session looks like for session 1 with our trainees and our trainer. Okay. Now for session 2, okay, since this is a series of 3 Saturdays, on the second Saturday, we had an activity on converting the STL file into a G-code file. Since 3D printers will read G-code files, the goal of the activity is to convert the output of the mesh mixer activity, the one that they manipulated and modified, into a machine readable file, and that's G-code. So as you can see here, our trainer introduced how to prepare STL files so that it can be readable by a 3D printer. And then, lo and behold, we trained our doctors, our medical professionals, to calibrate and to operate, to load materials into our 3D printers. So as you see here, this is our doctor trainee from Davao City. Our site in Zamboanga City Medical Center, and there goes Dr. Don Isla in FAB LAB Mindanao, and Dr. Rahmat here in FAB LAB Mindanao, who really used our 3D printer, use it on their own, since our goal is for them to really use it and capacitate and train these doctors to use their 3D printer. So now that they're done in the entire process of converting the DICOM file into an STL file, modifying the STL file based on how they want a surgical guide to look like, and converting the STL file into a machine readable file, and actual use of 3D printers. On our third session, we had our skills return demonstration, by which we allowed our trainee to exhibit those skills and do it from womb to tomb. So our doctors from Zamboanga City Medical Center, as you can see here, Dr. Justin Papabel was really the one to use it from start to end. And here, our doctor trainees from Davao City were really the one using the 3D printer, and as a result of the file modification activities. And this is also what it looks like here in the Iligan site here in FAB LAB Mindanao, where our trainees demonstrated their skills of developing anatomical models, up until we came up with the happy and joyous moments of coming up with their own anatomical model for surgical guides, maybe, or maybe for dry surgery applications. So as you can see here, the end result, the joys of having the end result. So 3 days, 3 Saturdays, 3 sessions with different objectives. Now, how do we move forward from this activity, and what did we learn? We were glad that we were given the opportunity to disseminate this, and Dr. Renter will be presenting in the International Conference for Additive Manufacturing on November, organized by ASTM. We will be sharing our learnings through this paper, Implementation of an Additive Manufacturing Training Program for Medical Professionals on the Design and Fabrication of Surgical Planning Models. But beyond the dissemination of what we did, we have some action plans that we hope the doctors who are here right now and the Fab Labs can participate. So first, we are having this nationwide roadshow as an information drive on the applications of 3D printing and additive manufacturing to a certain use case. In this use case, to applications on otorhinolaryngology-head and neck surgery. But for future applications and for future activities, that is why we partnered with the International Center for Theoretical Physics and Zamboanga City Medical Center. MSU-IIT has organized this to introduce what we can collaborate with. Now, what we can collaborate with are these coming activities. On November 22 to 24, 2021, we will be conducting another set of training for Fab Labs. So this training for Fab Labs, you may contact us, and we are extending this invitation not just to FAB Labs, but also makerspaces who can host doctors and who can train medical professionals in 3D printing surgical planning models. That's on October 22 to 24. So we are extending this invitation to the FAB Labs right now. So not just the FAB Labs. On 2022, this is the highlight. We will be training doctors in partnership with the FAB Labs that we train. Tentatively, we have scheduled it on March 2022, and we hope that you have signed up for the attendance so that we can have your email and include you with the invitation that we have. Else, you can contact fablab at g.msuiit.edu.ph. So as a prospect, we hope that if any of you here who are members of these societies, the Philippine Society of Otorhinolaryngology-Head and Neck Surgery and the Philippine Orthopedic Association, please message us. Okay, please message us, okay, through this email, as this will be our target participants. Actually, it's open to all medical professionals, but we hope that we can start with these two societies. So please message us in our message board, since we need your collaboration. Now, going back to how we transformed the long process and the time-consuming process of coming up with anatomical models with fabricators and having a very seamless process of bringing these technologies to the hospitals and clinics, to the doctors by which they are being needed through Industry 4.0 technologies. We hope that the FAB Labs around the Philippines can collaborate with medical professionals. Okay, so if you're a doctor, there's a FAB Lab, there might be a FAB Lab near you that you can collaborate with, and there are future activities that we can look forward on collaborating and partnering. You can also message us. Here are my details for FAB Lab Mindanao, and we hope that you can join us in this endeavor of bringing 3D printing to the doctors, to the hospitals, to the clinics through 3D printing training for surgical planning models.